basically the same information from the book, but it gives us an opportunity to talk about it and you guys to ask questions. There are 20 slides. We might get through them all today. If we don't, we'll finish them up on Thursday. I will be here on Friday also to help you with any of the labs. So this, a hard time today with words. So this one goes into more detail about strings and some things you can do with strings. Strings are very versatile, and there's a lot of things you can do. So, like we said before, a string is just a sequence of one or more characters, symbols, anything that's on your keyboard can be part of a string. A string literal is a value specified in the source code of a program. So it's the actual letter or string itself. It's not a variable pointing to it. It's the literal version of it. We're going to talk about some sequence types. So a string really is a sequence of characters. They have index numbers. You can figure out where each character is in the string. Well, we're also going to start talking about lists in this chapter, which is also a sequence type. Instead of just holding characters, a list can hold other data types. You can have a list of numbers, you can have a list of strings. So then you would have a sequence type with a sequence type in each element. So things like that. So what we're going to do is learn about some of the things you can do with strings. There are a lot of string functions that are already out there that you don't have to recreate. A string knows how long it is. So if you use len, which is abbreviation for length, and then you put a string in between, or a variable name for a string in between the parentheses, it will return the number of characters or number of items in that string. So this comes in handy when you start doing loops later, and you need it to loop so many times, but you don't necessarily know how long the string is before you get started. You can ask it to tell you when you set up your loop. Brackets, we use the square brackets to get to a specific index. If you put a number, you put the string variable name and then the square brackets with a number in between, it gives you that one element at that position. Now, when we have a long string, they each have what we call an index number or a position number. This is something that you need to wrap your mind around really firmly at this point. Computer scientists start counting at 0. So the first element in a string is at index 0. 0 is a number for computer scientists. Yeah. So you're going to hear me often talk about off by 1 errors. That means that you forgot that it started at 0 and your counting is off by 1. This happens a lot in loops, in comparisons, and when you're pulling things out of lists or strings, you get the element one further than you want it to be. So if this example here, if I wanted to print the 0 element, if I wanted A, I would put 0. If I wanted B, I would put 1. If I wanted, it's 26 letters in the alphabet, so Z would be 25, right? Right. Now, if I told it to tell me what the length of alphabet was, so I tell me the length is 26. So you always know the last index number is the length minus 1. And we're always going to start at 0, moving up. You can concatenate strings, which is a fancy word for you can add 2 strings to each other. When you add 2 strings together, and you use the plus sign to do it, you create a new string that takes the first string and puts the second string right up against it. So there's no space. So if I concatenate ABC 1, 2, 3, when I print it, there's no space between the two. Now, Zybooks will screw you up on this. Because the Zybooks labs, not all of them, but some of them will put that space in there for you. Don't count on it in IDLE. IDLE is not going to do that for you. I wish Zybooks did. So remember that. We have been formatting strings. Y'all have been doing some formatting. We're going to continue to format strings using that F in our print statements. That's a formatting a string. You're going to replace fields with, the curly braces and the replacement fields. Remember when you're using that notation to put the variable, to check, make sure you put the correct variable inside the braces. I was trying to do something and I confused myself and I swapped my variables and I got completely wrong answer. It's amazing. Happens to the best of us, even at my age. So just be careful when you're formatting things. There's other ways to do it without using the F format sequence, and that's fine. I'm not going to make you, Zybooks will make you use it, but when I'm doing projects and stuff with you, if you just do it with print statements with, I'm going to print this variable, I'm going to print that, and you do the formatting manually, that's fine with me. Or you can use the F strings, it doesn't matter. Just be aware that you have to make it look pretty for your user. You will, as you go through this degree, if you work as CS major, have whole classes on UX and UI, user interface, user experience. So that's a big thing right now. There are people that get paid big money to design user interfaces for games, websites, ordering things. Because you can tell if a professional has put together a website versus an amateur. Because it runs smoother, it's easier to use, it reads better, prettier. You don't want me to design your user experience on your website because I'm really good at the back end stuff. I can code the best of them. Do not ask me to match colors or tell you if something is visually appealing. That is not in my repertoire. I not an artist, that's for sure. So here are some examples of some formatting that you might see. We have done some of this. If you're doing like the one down on the bottom where you've got like all these extra curly braces and stuff, find a different way to do it. Don't confuse yourself and get lost in how many curly braces and whether or not they're all matching and stuff. There are easier, less confusing ways to do things. Put it on a couple of different lines, make a couple of different variables. Just make your life easier.
What is the point of that? What are they trying to say right there?
So,
2 words.
yeah,
Is it even words today? Wait, is that curly braces?
so these are all curly braces. So there's enough in there that it actually prints one set of them.
Yeah.
And then it does the math is one set of them. And then it prints. Look, don't do it.
Yeah, okay.
It's not worth it. It's useful up here when you're trying to do something, but don't do it. In my opinion, it's too much. And if you have a question like that on your desk, send it to me. I'm taking that off. Now, if it's math, parentheses, and order of operations, I'm not gonna feel bad for you because screenshot it, get with me. So we'll talk more about that. I firmly believe in the KISS principle of programming. Keep it simple, stupid, sweetheart, something. Just keep it simple. Yeah, you can impress people with how many things you can do on one line that makes you happy, but simple coding is more accurate, and you're not going to be as frustrated trying to figure out where you went wrong. Now you'll find other people that have different ideas on that, but as far as I'm concerned, simple and correct is much better than fancy and not correct. It's like the new math I taught my children in elementary school. All I cared about was whether or not they got the right answer every time. I didn't care what way they did it. So we have done some formatting, but we also have done some presentation stuff. So the presentation things are more about how many decimal places are showing. What is it? How does it present to the user and to the screen or to whatever you're putting it to? So some examples are, you have an integer, it's just a whole number. You have floats that have a decimal place on. You need a certain number of precision. You can tell it how many decimal places to print out using different formatting tools. Those are important formatting issues. Getting it to do your math for you inside of multiple curly braces, not as. Not for formatting. Yeah, you could have done, if you'd have done it as a variable, you could just use parentheses. Exactly. That's what I'm trying to say. All right, so you just make it simple. If you want the percent sign to show, there's a way to format that in. If you want, a binary number, you can absolutely have your numbers formatted as binary numbers. Does anybody want to tell me what 100 in binary is?
Yes.
Okay, tell me.
Yes.
I would like to tell you.
You would like to tell me, but you can't.
The answer is no, I cannot.
So binary numbers are actually covered in this chapter very, very briefly. I probably will spend a little bit more time with you because I enjoy converting binary numbers, and I can show you a shortcut to do it.
Would you?
Sure, absolutely. Would love to. So let me.
The answer was yes, you'd love to, but you.
I'm going to, if this will let me right on here. So if you look at this, if you start over here, if you start at the rightmost digit and you put a 1 here, and then you put a 2 at the next digit, and you double it every time, so 4, right?
Sure.
Everywhere there is a 0, ignore the number at the top. Everywhere there's a 1, add the number. So 100 is 4 in binary. Now, if I had my handwriting is horrible with this pen. Sorry.
You're using maps.
Well, yeah, I'm doing the best I can here. So say I had this number. If I usually tell you to draw a line up here, and I can go 1, 2, 4, 8. That's really bad.
Fine.
16, right? So if everywhere there's a 1, if I add those numbers up, I get the answer.
Okay.
So 16 plus 4 is 20, plus 2 is 22.
Ignoring the 0 values, right?
Right, ignore the 0 values. Now you can do it the other way. Say I had the number 25, right? I don't know why it works, but it does. So if the next one would be 32. Oh God. Yeah, just ignore that. All right. So this equals 22. right?
Sure.
Give me a number. Stay kind of small. Give me
What's small?
under 32. Give me something under 32. 27? Is that what you said? So if I have 27 and I want to convert it to binary, and there's a whole like slide for binary later, but we'll go into it now because it's fun. If what I do is I look up here at my chart that I drew, and I find the biggest number I can subtract from 27 without going over.
32.
Without going over. 27 is less than 32. 32 is
16.
over.
Right.
So you're not going to use 32. So 16, if I subtract 16
Okay.
from 27, I have 11 left, right?
Sure.
Can I subtract 8 from 11?
Sure.
So we're going to put a 1 there. And I'm going to take
So 1 if yes.
1 equals yes, 0 equals no. 4 will come, well, so that gives me 3, right?
Right.
Can I subtract 4 from 3?
No.
So I put a 0 there. I can subtract 2. And that gives me,
So you
oh my
just
God,
do
this is
one
horrible.
anyway.
Gives me 1. 1 subtracts from 1. So there you go. That's 27.
Okay, that's gonna take some getting used to, but yeah.
It's a whole lot easier than using to the n notation and doing it. There's a whole formula for how to do this.
Is this the modules that have like?
But it's n raised to the, it's 2 raised to the nth power. Figure out how to do it mathematically. And people teach this in networking because it's really, you use it a lot in networking for subnet mask, IP addressing, things like that. And my very first industry jobs were in networking, and they had these calculators for figuring out these numbers, and they had these formulas. And then one day I sat and down with somebody who'd been doing it for years, and he said, "That's garbage. Just do this." And I went, "Holy heck, that works!" And this also will help you convert to hexadecimal, and I'll show you that. I'll bring my tablet in Thursday and my pen that actually writes like a pen, and we'll do some of this. But you can take the binary numbers and convert them to hexadecimal really easy based on patterns. So, this is why I like computer science.
That's fun.
So I'm going to erase all that and get it out of the way. This is when I start doing things like this is when I start waving my geek flag up here going, yeah, I'm super geek. This is fun. But so just remember that when you're doing binary numbers and somebody shows you this really intense formula.
Do people get mad when you use that, or is it considered like somehow less?
People that don't know about it usually go, why didn't anybody tell me that? But also in industry, if you're in a hurry, a lot of there's calculators that do this for you really quickly. You plug in your number, you get binary decimal. Most Windows machines have that option. So, you can. Here's a chart in the guidebook that tells you how to do different things with formatting. You're doing precision. This one's important for you know how many decimal places you're going to go. If you're doing scientific precision, you put the number of spaces. You put the number and then you put the number of decimal places after the dot, that sort of thing. So this one would give me 2 decimal places. I needed 3, I would change the 2 to a 3, that sort of thing. So be aware they're there. If you need binaries, there's, you use B to convert it, that it's going to be a binary number, So we're going to talk about lists. And lists are great containers. So you put something in the list, you get stuff out of the list. It has index numbers again. You can add to the list, you can subtract from the list, you can sort the list, you can do all sorts of things with lists. And they're not limited to characters. They can be objects, they can be strings, they can be numbers. There are a variety of things can go into a list. They call the individual items in the list an element. So that's one individual item. So this is mostly just terminology. You know what a list is. You make grocery lists all the time. So in a computer, it puts them together horizontally instead of vertically usually. You have to format it to print it vertically instead of horizontally. The indexes, again, are going to start at 0. And the last one will be the length minus 1. Very similar to strings. They have a lot of methods already pre-built. And I'm going to show you how to go find those before we leave, before we get out of this chapter 2 in the standard library. Because the standard library is going to be your friend as you learn to code. And even after you have been coding for years, you're still going to go and look stuff up in the standard library. So a method is the same as me saying function. That gets interchanged a lot. Python usually calls them functions. Java usually calls them methods. But it's an instruction that object can do. So the string I create has some functions or methods that it can call on itself or do to itself. Append for the list means I'm going to add one at the end. It appends it to the end. I can pop or remove one also. Now, why are they called the same thing? Because they're slightly different. In the old days, you would pop something, and that means that it would take the last thing in off. You would pop it off the top of the stack or whatever. But basically, we're removing an element. Lists have come a long way. So if I have these examples and the list, when you're creating a list and you want to go ahead and fill it while you're creating it, you use an equal sign to assign it, the square brackets to indicate you have a list, and each element in the list is separated by a comma. Right? That makes sense? It doesn't look like this necessarily in other languages. There's slight differences. I got a couple people nodding that have seen them done differently in other languages, but for Python, this is how it's indicated. When you tell it to print the list, it prints just like that with the square brackets and stuff around it, unless you've given it some formatting instructions. When I append something to the list, so our list originally has 10 and BW in it, right? If I do my list dot append, whatever's inside the parentheses is what we're adding. It becomes the next element at the end. So ABC then becomes our third element. If I pop takes a number. Why does pop take a number? Because it will let you select which element you're removing. So in this case, pop wants to take the element 1. So that means it's going to get the BW because 10 is at 0, BW is at 1, and ABC is at 2. Yes, sir.
So I'm just
Say that again?
So if you put in the parentheses of pop 0 or 1.
No. It could have been 0, 1, or 2 because at that point our list had 3 elements in it. So if we do these in order, the first command created us a list with 2 elements. We appended, now we have 3 elements. After we pop, we're back down to 2 elements. And then when I do remove will let me actually tell it data to remove. I don't have to give it a number or a location. I can say, I'm looking for ABC, remove it. It's going to remove the first instance of that. So if ABC had been in your list multiple times, it's only going to remove the first one it finds.
Back up like 2 seconds, or you say on the print at after append and everything, that is going to print.
So
it's gonna print that, right? The output's gonna be after a pin
Yeah, a pen comes first.
is my list.
After it removes, it's gonna remove things first, then it's gonna print. So it does everything in order it comes to it. So if I tell my list right here, oops, back up. If you tell my list right here to remove ABC, it's gonna remove it before it prints. So it removes it, then it prints what's left. And if you pop something off, it's gone, or you remove something, it's gone. Unless you saved it into a different variable. So you can't go, oh, I just want to remove it while I print it, and then have it for my next, and it's not like it's gone. So if you use pop and remove, they're gone. No getting them back unless you have another copy of the list somewhere else. A hard lesson to learn sometimes. You don't want to be the person that removes stuff from the database and it not be retrievable. So there's more functions that you can do. Like I said, the list says how long it is. It can use len for length to find out how long it is. You can add two lists together, just like you do strings. It creates a new list that's the two of them much together. It will find the minimum element in the list. You can find the maximum element in the list. You can sum up the list for numbers only. Only if your list is integers or floats. It will not sum up characters for you. You can get to find the index of a value using the index and then the value. You can count how many times the value is in your list using count. There's all sorts of things you can do, right? Now, if you notice on these, some of these have list dot in the function call. That means that it has to be called on a specific list.
That's fair.
The others are kind of pre-built into the class. So you can do, it's kind of like when we did int, and then we put something in there, it changed whatever it was into an integer. If you do len and it's something that has a length, you can put just about anything there. Now, if you're going to do index of or count of, that needs a specific list. You'll use the variable name of your list, dot that, because we want to do it on that list. Make sense? It's going to make more sense as we do it. Hopefully, fingers crossed. The more we practice it, the easier it becomes. So I had a student email me today and asked me, a student I had last year or last semester, email me and asked me how to remember Java functions and Java syntax. And the answer they wanted was not the one they got. The only way you'll ever memorize syntax and formatting for programming languages by practicing it. There's no quick fix for remembering how to invoke functions and things. You just have to keep practicing it. So the common data types are the number types and the sequence types. You're going to see a lot of these as we move forward in computer science. You're going to see a lot of ints and floats and strings and lists. And if you get into Java, you'll have array lists and arrays and things like that. So anything that are collections, sequences, and then you're going to see a lot of your numbers and your characters. Questions? We've already been doing this some. We've already been doing conversions. We haven't really talked about what they were. Well, I did a little bit when I taught, but the book didn't. They just threw it at you and told you to do it. So remember, if we need to create or force a piece of data into a different type, then we're going to use our casting or our type functions to do that. You can make floats into integers. You can make strings into integers as long as they're the numbers. You can take anything pretty much and make it into a string. Numbers, letters, symbols, whatever. And because Python reads all input in as strings, you will be doing a lot of conversions if you're trying to do math. So be aware that float and int, when you're getting user input, if it needs to be a number, you might as well go ahead and have in your head, I'm converting this as I get it. Y'all actually lucky. Python is not as strongly typed as, say, Java. So it lets you create variables without knowing what the type's going to be. And then it fills it in for you after once you put the data in it. When you're in Java, you have to know at creation for your variables what type is going to be, because it expects you to tell it the type.
Oh, it's list.
I haven't ever programmed in list.
No, I mean, list.
List.
Job.
Oh, list in Java is
Yeah, because that's the first thing I noticed. I'm like, wait a second, you're only mobile, but those variables in a list.
you can do that with array lists.
Yeah, it's array list. You know, list, I think it has to be, this is the type.
It's the reason you'll see that most people are depreciating lists in Java and using array lists. And let's not confuse the rest of the class. I talk about something that's not relevant. Be happy to discuss that with you after class, though, if you want. So we have binary numbers, which I just showed you how to convert really easily. That's what the computer's taking everything down to. That's the ones and the zeros. Decimal numbers are our base 10 numbers, you know, where everything goes up, each thing goes up by order of 10. We have 0 through 9, then we have the tens place, and then we have the hundreds place, and we have the thousand place, other decimal numbers. Sometimes you will see binary numbers called base 2 numbers. And that's because each one of them can be written as a math equation 2 to some power to get. Questions? Let's talk a little bit about modules. Before I throw my phone across the room. I'm trying to move it away from the microphone where it's not being picked up. So modules can be several different things in Python. There's scripts, and you see when you're in Zybooks, it uses a script to run instead of a main. That's an example of a script down there. We're not using a lot of scripts this semester. Be aware they're there. Read a little bit about them. Keep them in the back burner. But this class is not going to touch on them that much. So this is more of a foundation class. Modules are usually a file or a class that's already been created that you want to use in your code. We've been importing some modules. We imported math, where we didn't have to rewrite all those math functions. But you also could create your own module and import it into stuff, or into your code, or into other modules. We're not going to do that so much in this class, but we are definitely going to use that standard library a lot. So you guys are going to be importing from the standard library. Import is the key word that says, hey, go find this file, and we're going to use it. If it's in the standard library, Python will automatically, the interpreter will go out looking for it because it knows it's supposed to be there. It downloaded when you downloaded the Python IDE to your computer. Hopefully, unless you did something weird, it should be there. Java is not necessarily as easy. You have to sometimes go and download the individual packages themselves. But again, that's Java. A dependency means that for your code to work, it has to be linked or has to have imported another module. That module you imported is a dependency. It is dependent. Your code is dependent on it to run. This is mostly vocabulary. So, for example, I could import a class called my funcs, which is the short for functions. And then I can use anything that was in my functions. Now, is that a standard library module? No, that would be something that I would have written myself. So, an example, I used to give my high school students a project where they had to create a zombie game, a text-based zombie game. Nothing graphical. Don't get too excited. And they had to build a class that defined what the zombies were. And then they had to build a class that told me whether or not they were going to be devouring an adult brain or a baby brain. And then how much energy they could. Right. But the three things, okay, teenage boys, they're all a little morbid. They really enjoyed it. Didn't. But the zombies don't work without the information from the victims. So you have to import both of those modules into the game module for it to work. I really needed a new example. Y'all are gonna like break me over the coals for the zombie one. So I'll be less morbid from now on. Built-in modules, those are the ones that Python come downloaded in your Python already. They're great. They keep you from having to do things like define a string, define square root functions, define print. You know, these are things that are already built in. There's a sys path, which is a system path that it goes and it looks for, and that's how it finds them. It knows they're there. They have keyword names. It goes and finds them. And it loads them up and you can use them. So if you're importing an entire module, you use the import and then the name of the module. If you only want certain pieces of it, you can use the from statement, and then you do from the module and then the individual little piece you want to import. I'm gonna be honest with you, 99% of the time, I just import the whole module because the likelihood that I might need something other than just the one little piece I picked later when I'm coding for long, it's pretty high. So might as well just get the whole thing and be done with it. Now, if you're running on a computer that has memory problems, that you don't have enough memory, or it takes up your program's running and taking up too many resources, then you might scale it down. But most of the time, I'm gonna, in my examples, you're gonna see import in the whole module. So the standard library is your friend. I always have a standard library in the back of my mind, or at least most of the time pulled up on another screen when I'm coding. So I can go and see if something exists already. I don't have to do it myself. Right? So these are some examples that they show you in the Xi book, but if you go click on the link in my PowerPoint, it opens up this window that takes you into the standard library. And there's all sorts of things in the standard library. So I love the quick search bar. Python has a quick search bar. That's great. So say I wanted to know what I could do with strings. I could type string in here and it will bring me here. I could click on string and now look, I can see all of the different things available to me with some description. There's functions, there's syntax examples. I can go through all of this and find more information at your fingertips. Now, is it written in the simplest of English? No. Programmers wrote this. But the visual examples sometimes are great. So go look at these boxes and see if they've got something that's what you're looking for. I can go back to the top and decide that I need math instead. And usually it's the first thing there. And I can come in and go find out that there's a ceilin function, and then there's factorials, And greatest common denominator. You know how hard it is to write greatest common denominator yourself? Are there any math majors in here that want to talk about the formula for greatest common denominator? Because it's not easy by yourself. But there's a math function that'll do it for you because it's already created. We did it for square root and stuff, you know, so there's logarithmic functions, square root, cosine, sine, tangent, all this stuff's already in there. So everybody that told you had to be great at math to be a computer programmer, were wrong. You have to be able to know what piece you need, but you're welcome to go and get it out of the standard library once you know what piece you need. You're going to have to put formulas together, but the math itself, the computer's going to do for you. That always bothered me when I was teaching high school, that they always told my students, that the guidance counselors and stuff would tell students, oh, you have to be good at math to take.
You still gotta pass calculus and all, I mean.
You do have to pass
1 and
calculus,
2 and not be 3 and.
but you can pass calculus. If I can pass calculus, anybody can pass calculus. You can pass calculus with some hard work, but nobody's saying that you have to do calculus in your head to be a computer programmer. You have to understand how the higher order math works, and there are functions and there's formulas out there, and you have to be able to translate those formulas into computer code. Calculus is not necessarily there to see how good you are at math. Calculus is there to see if we can teach you a different way of thinking about the world. Because calculus helps us model things, right? There's a few people nodding along with me that don't think calculus is the evil bane of their existence. And I'll be honest with you, I took Calc 1 twice before I withdrew from it. I withdrew from it the first time.
You find it easy?
No,
Okay.
I worked very hard at it, but I'm gonna tell you the truth. I took Calc 1 when I was getting my geology degree. I needed calculus for geology, the study of rocks and minerals.
Guess you could say it was a pretty rocky journey.
It was that a bad pun. It was a rocky journey. But you need to understand how calculus works. Why do you need it in geology? Because you have to know flow dynamics. You have to know how the water is going to flow through different materials. You have to know how the pollution is going to flow through different materials. You have to know how long it's going to take that magma to flow down the hill and wipe out the town.
Peter can do it. Said that.
But the computer could do it. But if you don't know which formula to apply, you're messed up. Because you guys, as computer scientists, are creating those programs that other people are using where they don't have to know calculus. Watch out, world, here we come. And that is all the new content for those 2 chapters. Feel free to send me questions or show up Thursday and we'll